Hey guys, today is Tuesday, November the 10th, and for today we're going to take some notes, and so you're going to need your periodic table. It's going to be helpful for you today. If you don't have your periodic table at home with you, then obviously just look at one online, and it is perfectly fine. And so we're going to take some notes about bonding. So what we basically want to see is how do elements like, hydrogen and oxygen, why do they come together to make water? And that's called bonding. Today's example we're going to use is with table salt, as you can see there on the screen. So table salt is something that you use on your food on a daily basis. Maybe put it on your eggs this morning or something like that. And so table salt is really just sodium and chlorine. Now, sodium itself is an alkali metal. It's in group 1, and alkali metals are really reactive. Like if you threw sodium in water, it would blow up. Chlorine, meanwhile, is a gas. And so these two things separate are not good for you. But when they combine, when they what we call bond together, it becomes something we can use. So let's figure out how all this works. All right, so I'll write your notes for you on the board. Okay, so what you want to know about bonding is with bonding, we really got to worry about the valence shell. Now remember, the valence shell is the very outer shell. So no matter how many shells you draw, 1, 2, 3, or 4, the valence shell is the most outer shell. So whichever element you're on, remember, it's the outer shell is the valence shell. So the valence shell, or the outer shell, wants to be happy. And in order for it to be happy, it needs to get to 8 electrons, all right? Because 8 electrons fills the whole shell, with the exception of shell 1. Shell 1 for hydrogen and helium obviously gets to 2 because only 2 electrons go in the first shell. But every shell after that, it wants to get to 8. So 8 is the magic number, all right? It wants to get to 8 electrons. So keep that in mind. It's always trying to get to 8 electrons. So if we look at our periodic table, all right, one group that really stands out is this group over here, the noble gases. And the noble gases are what we call inert. And the noble gases are inert because in their outer shell, okay, in their valence shell is equal to 8. Obviously, with the exception of helium, which it only has 2 in the valence shell, but the rest of them have 8 in the valence shell. So all the other atoms, they want to be just like the noble gases, all right? So all atoms want to get to 8 electrons in the outer shell. So one thing that you guys need to remember is those outer shell, the valence electrons, you should already know how many electrons are there. If you're in the first group, there's the number 1A, and this one has 2A. And then you come over here and we got 3A, 4A, 5A. And when you get to the noble gases, it's 8A. And so if you're not seeing where that is, it's right there at the top of your periodic table, okay? It's right there. It's right there at the top of your periodic table. Right there where the group number is, right below it is a number and an A, all right? And so there you will see the 1A, and there's 4, 5, 6, 7, and 8A. And so that number tells you how many electrons are in the outer shell. So it's a real easy place for you to look, and you already know. So let's just go ahead and do an example. All right, so how do we find out how these atoms get to 8, how they're going to bond? So if we look at sodium, sodium is number 11. And if I was to draw sodium, because it's in period 3, I would need to draw 3 shells for sodium. And so as we did yesterday, sodium is number 11. And if I do my math here, all right, 23 minus 11, all right, it's got 12 neutrons. And then I'm going to put in my 11 electrons. I can put 2 in the first shell. All right, so I put out of my 11, I put in 2. I need 9 more. I can put 8 in the second shell. I put my 8 in the second shell. Now I'm down to 1, and that 1 goes here in the outer shell. So right now, if you look at sodium, and here's my little sodium man over here, all right? My sodium man right here is thinking, hey, if I could just lose 1 electron. If he could just lose 1, because look, if he was able to lose that 1 electron, he would be left with 1, 2, 3, 4, 5, 6, 7, 8. That's what he's trying to do. All right, but right now, he's still got that extra electron up there. So let's come over here and let's draw chlorine. All right, and so with chlorine, chlorine's also in period 3, so it's got 3 orbitals. And chlorine is number 17. So it has 17 protons. And if I do my math, 35 minus 17 is going to get me to 18 neutrons. And then I'm going to put in my electrons. So I need to get in my 17 electrons. So 1, 2 in the first. I can put 8 in the second. All right, so I've used up 10 of my 17, and that means I need to put 7 more in the outer. All right, so my little stick figure here for chlorine, he's really thinking, if I could just gain 1 electron, he'd be happy. So if you're looking at the stick figure guys there, this stick figure guy, chlorine, he really needs to gain 1 because he's got 7 in the outer shell. If he had 1 more, he'd get to that magic number of 8. Remember up here we said wants to get to 8. And if you look over here at sodium, he's thinking, man, if I could just lose this 1 in the outer shell, man, I'd have 8 sitting there in the next shell down. So that's how they bond, is they help each other out. So basically what happens is this electron comes from sodium and comes right down here. And now it is essentially lost its electron. That's gone. So now it has its 8 right here in this shell. And this chlorine has picked up the 1. And so now it has 1, 2, 3, 4, 5, 6, 7, 8 in the outer shell. And they are both happy. But we don't want to spend all our time drawing this every time. It takes way too long. So there's another way to do it. So the way that you're going to do it is this way right here. And so you would just write out the symbol for the element. And over to the side, I've put some notes on each one. So if we pay attention to our periodic table, sodium is in group 1, and at the top it says 1A, which means it has 1 valence electron. So all I got to do is put that 1 valence electron. Meanwhile, chlorine is in group 17, and its number is 7A, if I looked at the top of 17. So that means it has 7 valence electrons, and this is how I would set it up, just like this. Because remember, it wants to get to 8, so notice there's a blank spot right here. There's a blank spot looking for an electron. So what's going to happen is we would draw it like that, and we could just show that this 1 electron comes over from sodium to chlorine, and now chlorine has 8, and sodium got rid of the 1 that it needs to get rid of. And so what we have made is NaCl, or what we call salt. Last thing on your notes is something called an oxidation number. So whenever something loses an electron, when it loses an electron, it now has more protons in it, which makes it a positive oxidation. If something gains an electron, it now has more electrons than protons, which gives it a negative oxidation number. So in the case of sodium and chlorine, sodium, if we look back at our example, sodium got rid of an electron. So whenever you lose an electron, you become more positive. So sodium becomes positive 1. Meanwhile, chlorine, if you look at our example, chlorine right here gained an electron. And so whenever you gain an electron, you become more negative. And so chlorine became negative 1. All right, you have a paper that is attached there in classroom, and on the paper you need to fill out the information that you see here. And so the information that you see here, you need to put in the symbol for chlorine, which is Cl. Chlorine has 17 electrons. It's in 7A, so that means it has 7 valence electrons. It would like to gain 1 electron. Remember, if you gain an electron, that makes you more negative, so its oxidation number becomes -1. We did that one in the notes. Let's do potassium together. Potassium is K. Potassium has 19 electrons. It's in period 1, or group 1, 1A, so it has 1 valence electron, which means it would like to lose that 1 electron, which makes it more positive by 1. And we can do one more example. We can do magnesium. Magnesium's Mg. Magnesium has 12 electrons. All right, magnesium is in group 2, which means it is 2A, which means it has 2 valence electrons. And so still, it's a lot easier to get rid of 2 than to gain 6. So it would like to lose these 2 electrons, which would make it positive by 2. All right, so this is the paper that I'm referencing. It is in classroom for you. You can print it off, or if you don't have a printer at home, then just simply copy this onto your own sheet of paper. All right, thanks guys. Have a great Tuesday. Stay safe.